Hello. This is the narration of the artist. I'm not British, but I am choosing to use this voice because people tend to trust its sound and inflection more. I am not sure how we implicitly trust sounds. I am not sure how we implicitly trust what we see, either. But it is a lovely conversation to have with you staring at this campfire, which of course, is simulated like my voice. We are in a physically based rendering game environment. Everything is designed to simulate the world as realistically as possible. I would like to tell you a story about computing. If you get bored, that's okay. Maybe take a walk. Once upon a time, computers had no visual interface. Or at least, the interface was the actual mechanical hardware. However, there was a desire for screens, interfaces that mediate the computation and the user. There was also a desire to visualize three-dimensional objects in real time. From the 1960s through the early 1990s, a graphics pipeline was used to render information and emit light on a screen. In the mid-1990s, the architecture of this pipeline became programmable itself, a computer on its own, and this is the beginning of the Graphical Processing Unit, GPU. With a GPU, a division between software and hardware is no longer possible. Before, computer architecture was linear, following orders in sequence. This way of executing tasks seemed given a separation of hardware and software, just like any supposed transcendental mind from the body. Graphical processing units changed this supposed separation, introducing new computing architecture called parallel processing. The GPU could now delegate tasks to concurrent microprocessors depending on the bit need and capacity. Thus, software programming now accounts for the architecture of the computer. Here, I am interested in the graphical performance of light. This particle system divides the labor of rendering particulates non-linearly. Particles closer to the center of the radius are updated more frequently than particles on the edge. Forgive me if I'm being rudimentary, but I want to remind you that numbers are representations, and counting is a method of representation. In the method of counting ones, to say a thing is one is to determine what, and that, one is. When 1 and 1 and 1 add up, an effort to group ones as alike, we ordinarily use the decimal system, base 10, to represent this group. The spatial significance of each digit represents the number of ones, then to the left, ones as tens, ones as 100s, and so on. Frequencies, the method by which all of this experience is possible, move up and down, on and off. There are two options as yes or no. This binary system represents numbers as base 2. The spatial significance of each digit to the left increase by an exponent of 2 instead of 10. These digits are literally stored and transmitted as frequencies. 32-bit hardware means there are 32 digit spaces for zeros and ones. 32 spots to hold count. Whether 32 or 64, the precision of computational numerical representation is limited by its physical capacity to store frequencies. With the development of the graphical processing unit, and the desire for screen naturalism, the range of values to represent light needed to correspond with the range of visible light. With this, representation could become true emission. A new number schema arose called floating point. While floating point is still represented by frequencies, its on and off, yes and no, only approximate real numbers. Floating point splits its bit architecture between space used for a significant number and space used for an exponent of that number. The exponent is used to scale between its smallest and largest possibilities. With 64-bit architecture, and 11 bits reserved for the exponent, double precision floating point allows for a dynamic range of numerical values between 2 times 10 to the negative 38th power and 2 times 10 to the 38th power, which, of course, I am representing to you in base 10. Floating point can simulate continuity and the infinite space between things. When you take a photo with your phone, floating point is used to represent the luminosity value of each pixel. This process is called high dynamic range. There is a scene referred to as the allegory of the cave in Plato's Republic. This is what I have imagined for you here. In the allegory, firelight is considered an artificial light, a limited tool used to present an unstable image of the world. What the allegory does not account for is what might be learned from artifice. Creations like parallel processing and floating point broke computing and counting as they were. In the reach to represent visual things, other worlds became possible.